All right, I really want to thank Sumner and Kim for bringing me out here, because this is just so exciting to hear about some of the issues, to think about how different the topography, the populations of birds that you're dealing with might be from what we have in our region, but also some of the similarities. So what I'm going to do is not give you a concise little story of like a study and its results. I'm going to pull from a variety of, give you a variety of examples, because that's really what I'm here today, is to show you the different tools that we've been using. So what I want to do is first talk about why we needed region-wide monitoring in our area, and the genesis of what we call NERMIN. Examples of what NERMIN does best. The idea is that we can integrate methods that are out there, very different methods, that we have available to us, and it combines expertise. No one here in this room could possibly be the master of all the different techniques, issues, and good things and bad things about these different tools. And it really pools resources. Again, no single entity, agency, office could afford to do the kind of work that we're able to do by working together. And ultimately, what has been driving this, and what we've been able to do, I have to say, I think, quite satisfactorily, is to inform policymakers about what some of the issues are, either what more information is needed, or what information that we now know. And also, one of our roles is to make the information available to the public, and to get the public involved in what we're doing. So, the Gulf of Maine region is extremely important. We think it's extremely important because it hosts all major taxa, a very diverse species assemblage through there throughout the year. We have representatives either breeding, migrating through, or wintering in our region from all major groups. But over 80% of the migrants that come through our area are breeding in the Arctic or the northern boreal forests. And of course, those are the regions that are going to be experiencing the most rapid response to climate change. What we knew about the Gulf of Maine region for a long time came from early radar and orientation work. So back in the 1970s, we had radar here up in the Bay of Fundy area done by Richardson, showed that in fall migration we have a lot of birds coming down through the Bay of Fundy, being funneled down through that area. More recently, Phil Taylor and his students have been doing a lot of radar work here in the southwest tip of Nova Scotia, and they've shown that many birds are continuing to make a direct flight across the Gulf of Maine and fall to southern New England and continue on to the wintering grounds. Many birds are making a beeline straight towards central Maine, and many birds are heading northwest to cross the Bay of Fundy. In the spring, we know from the radar work done in the 60s and in the 80s that many birds come up the northeast coastline and continue in a direction to cross the Gulf of Maine to head to the Canadian Maritimes, and many birds are hugging along the coastline. And from our own more recent work, both spring and fall, working with individual birds and asking them where do they want to go, and we capture them, which we can do very easily by then releasing them at night with a little tiny glow capsule on there and looking at which direction they want to go. Both in spring and fall studies, we found that birds make a whole variety of decisions based on their body condition. So birds that are carrying a lot of fat may prefer to remain offshore if they're captured here at Appledore Island, or out here along the coast, playing a more risk-prone strategy, if you will. Birds that are carrying less fat move back towards the mainland and away from the coast. But the bottom line is the Gulf of Maine is extremely busy. We have many, many, many birds that move along the coast, overland and along the shoreline, and many are making overwater movements across the Gulf and the Bay of Fundy. So there's a lot going on there. But when we started feeling when I say we, I'm going to include my fish and wildlife colleagues in the region, we're being asked about coastal and offshore wind development, and to come up with areas that were believed to be perhaps less safe, less risky, or high risk. We actually realized that most of the monitoring, the long-term monitoring in our region, was done at the southern end of it or the northern end of it. And we knew extremely little about the major part of our region. And so that prompted us in 2009 to form a collaboration with National Audubon and set up 3 standardized banding sites here along the coast of these islands. So it was a pretty standard banding protocol, setting up mist nets. We also did standardized visual surveys and collected data on species, sex, age, size, mass, and fat of the birds. Now, to give you an idea, before I show you the results, give you an idea and put this in context, these are the totals for those banding stations for that year. And I just want to point out that, keep in mind that Manamit Bird Observatory really is the workhorse of long-term monitoring in our region, where they run their nets 90 days with 50 nets and a whole tribe of nymphs and satyrs running around checking nets and banding. So how did we do with our little sites in a very extremely small crew? With our 3 little sites, we had almost 5,000 birds, and almost over 3,000 of those came from Matinic Island. My student Adrian banded over 3,000 birds herself. And this was collectively done with 1/3 of the effort in terms of net hours and number of nets as Manamit Bird Observatory. So what we were finding is this mid-coast Maine area is a real hotspot for migratory birds. In fact, with the visual surveys, you could stand out there for half an hour, and literally count 4,000 or 5,000 warblers coming on shore on a regular basis during the morning hours there. And extrapolating that out, then we estimated that within a 10-kilometer range, it's not unlikely that 250,000 to 500,000 songbirds pass over that Matinic Island area. So we continued the banding for several more years, and we've still kept Matinic Island in the running, but we changed a few of the sites as various resources came in and out, and Acadia National Park wanted to get involved. But the bottom line is 80% of the totals for each year of the banded birds each year were caught over Matinic Island. To date, collectively in that small area of mid-coast Maine, we've banded over 40,000 birds. So after the 2009 data, and we saw that we really benefited by working together to put together these efforts, we held a workshop. And in January in Orono, we already were working with the National Park Service and Fish and Wildlife and the State Inland Fisheries and Wildlife Group, but we brought in Phil Taylor from Acadia University. He was very much interested in what we were doing because he works here and running the Atlantic Bird Observatory. And that's when we founded the Northeast Regional Migration Monitoring Network. That following fall then, we put together what we call the Power of Partnership, and each of us were able to bring our collective resources and expertise to put these different tools together. So Phil Taylor brought in surveillance radar, we had banding operations going on, we were continuing on with individual orientation tests, visual surveys. We take blood samples to look at how well the birds are doing, how they're using fat or burning fat in certain areas. I'll talk a little bit more about stable isotope measures from feather samples. And we ran passive acoustic surveys to monitor what's going on overhead during the night, and also radio telemetry. And I'm going to talk about each of these, most of these, as we go along. The following year then, we had something to talk about. So the following fall or winter, we had the second, or I guess it was the first official meeting of NERMAN, and we had a whole variety of state and federal agencies and academic institutions and NGOs presenting not only work that they had done, but also proposed work. What do they need to get done, and then who could they work with to accomplish their goals? The second meeting was also held at Orono. We called this the Crossroads of Migration because we were interested in how birds were moving over the region, and it was expanding. We had people from a whole variety of agencies and entities. And this past year was our 3rd annual meeting, what we called Movement Mania, because we found out with this new technique I'm going to talk about that everybody was getting on board to look at the movements of individual birds as well as using other techniques. So it's really expanded. And also we've changed our format a bit since we have so many people that can now give updates on ongoing projects, talk about proposed work and get input, and then group discussions. What are the issues, what are the resources that we need to have to do some of this kind of work? So we had that on day 1, and on day 2 we held workshops to talk about some of these techniques. We had a workshop on banding and acoustics and the automated radio telemetry system that I'm going to talk about. So what started out in the first 1 or 2 years has really grown. In fact, I couldn't even fit all of the icons of agencies and what have you that are in there. But we have over 40 participants. So what started as about six people working together has grown within 3 years to quite a big group. We have a web page, and on the web page then we have where people can upload descriptions of methods, standardized protocols. We post reports of studies as they get written up. We have them broken down by resources that might be available, papers, etc., on the different taxa. And then we also have another set of pages where we feature groups that we have websites. Each group can post updates and that sort of thing. But the bottom line is we keep an active email list of participants. We also contact people that we think might be interested and ask if they want to participate. So we're out there constantly looking for people who might be interested in what we're doing and to join us. Try to keep a quarterly email, little news blast going. That's kind of tough, but we have that web page, then we have our annual meeting and workshops. Our next workshop is going to be in Nova Scotia. So what we're trying to do then collectively is trying to understand who uses the Gulf of Maine Flyway, which of course you would want to know in your region as well. We're trying to understand the temporal and spatial patterns of migration that are going on in our region. And we want to ask, because we have some interesting topographical features, as you do here, we want to ask how are birds responding to those features? How are they using them as taking off points or landing points, etc. And finally, how do we map habitat use? When I say map, I mean put down and try to follow how, in what way individuals are using habitats, trying to identify important stopover locations and flyways in our region. And the major approach then is to try to look at these concepts across different scales, from understanding what's going on with respect to regional flyways, identifying species and populations that are using our area and in what way, and then what are individuals doing. So we have this whole variety of tools, and I'm going to talk, I'll give you an example of how we're using some of these tools. We try to integrate these because the bottom line is identifying flyways, identifying potential risks, and develop management plans based on that. So that's really NERMIN in a nutshell. And so I'll just talk a little bit about some of these techniques. Obviously, I think we're all familiar with banding and visual surveys, the idea of trying to find out what's there and why. When we start talking about locations and where you either see birds or capture birds, we'd like to know what's the value of that habitat to that bird? Why did it stop there? Why did it leave, etc. In some of our areas along the coast, in this case, this is actually Petite Minian Island, we only have one tree on the whole island. It's one little spruce tree. And so it gets, of course, heavily surrounded by mist nets, but we have mist nets throughout the rest of the island. And then one year I said, you know, if we had more cover, you'd actually get more birds. And so we transported Christmas trees and spruce and alder and that sort of thing and stuck them out. And sure enough, we were able to at least sample birds that had landed. Because if you're not out there by dawn, if you didn't have a tree, these birds take off and leave because the gulls hammer them on migration. There's no cover. However, birds do land there. So this provides some type of value to the birds, but in terms of trying to measure food and stopover, that sort of thing, you could easily tell that this is not that kind of site. Some locations provide cover from predators, but not a lot of food. Surprisingly, on the Tinnick Island, where we've caught in just a couple of years over 20,000 birds, running just a few mist nets, we get extremely few recaps within a season. In other words, we don't have individuals staying, landing, staying, fattening, and then leaving. They come, they're gone that day. But there's a lot of vegetation there and cover, so it may be a place for them to use that site not for food so much, but to rest, catch their breath, and get reoriented to where they want to go. Now, most mornings in our area in fall, we have foggy conditions. So for a lot of land birds, they know what general direction, they see land, they can stop and get reoriented and know where they want to go. But we know that in this case, birds aren't using the Tinnick to actually fatten. So what we've done, what's in the literature, of course, is trying to identify migratory stopover sites by the type of value that they could be to birds. So for example, you might have the fire escape where you've got to land somewhere, anywhere, it doesn't matter where, and it saved your life to do so, but it's not going to provide any other resources for you. How important is that? Well, it could be extremely important to populations flying in a region. A convenience store, we've all had to stop, get a quick bite, put a little gas in the car, but move on. You don't want to stay there very long. There's no place to sit and rest and relax. And then we have the full-service hotel where you can stop, rest, relax, really replenish your energy and move on. So those are the three categories of stopover sites that people have started to apply to habitat. The thing is, though, just because you catch a bird, so here's Matinic, and these are mist nets, and we've got them set up in different types of habitats. The thing is, just because you catch a bird in a particular site, what does it tell you about that individual's relationship to where it occurs? Remember, I just told you, these birds don't stay. They get caught, they get banded, they're gone. And so that's problematic because that's what we really want to know. And I'll get back to that question in a minute. When we look at long-term banding trends, this is from Nanumit Bird Observatory, 30 years of their spring banding data. Overall, you can see that the number of birds banded when they've corrected for net effort here, I guess the times when the little nymphs and satyrs aren't always working as well as they usually do. But you can see it's declined, and of course I'm sure a lot of long-term monitoring sites would show the same pattern. But we don't know what breeding populations explains this. We don't know which populations might be declining and represent this trend. Well, unfortunately, even though we've banded over 40,000 birds in our area, in our sites, this is not counting Nanumit, this is just us, and we have very, very few recaps, very few incidences where birds that are captured in our nets are actually recaptured somewhere else. And I have to also mention, most of our birds are hatching year birds. We have that hatching year effect that goes on. So we have our little star is Canada warbler, banded at fall in Matinic, and the following spring it was encountered up in Ontario. And so this was a bird that probably was born in Ontario, and as we have now, copious evidence that we have a huge proportion of birds coming from the west. So you can't rely on recaps to tell you where your birds are coming from, but what we use then is stable isotopes as biogeographic markers. And I won't go into a lot of detail. I'm sure a lot of you are familiar with this, but we can use discussion later if you have any particular questions. But clearly, the stable isotope form of hydrogen is deuterium, and that is in rainfall, and it falls in certain patterns across the continent, and it gets incorporated by plants, which get eaten by insects, which get eaten by birds. And so what you end up then is getting a relative strength of that signal depending on where the birds grew these tissues, either claw or tail, or different components of the blood. So what we do is take tail samples. We've also taken blood samples for a more recent indicator of where they've been, and then try to map out then where they may have come from. When we look at over 400 birds for which we had feather samples for captured in our region, and I've plotted here then this cline, this is the cline, if you will, going from here to here, of the deuterium signature. You can see that most of our birds that we capture, is the relative frequency, most of the birds that we capture have signals that make sense. Here's our region, that have signals that make sense. They're carrying this kind of isotopic signature. But surprisingly, over almost 20% of our birds have signals that are indicating that they come from breeding populations much further west.